Hello there, everybody. This is section 4.4. We're talking about Pythagorean theorem and the distance formula. And the first vocabulary word we want to talk about is a leg and hypotenuse. If we had, this is all dealing with right triangles. Let me make it very clear. Everything has to do with a right triangle. So just give you a little pictorial here. If that's a right triangle, your legs are any of these two sides, the A and the B. And the A could be on the other side and the B could be on the other side. It doesn't really matter which one's A and which one's B. The important thing to notice is that, excuse me, where is the right angle? The right angle is right here. So the side that is opposite that right angle is always called C, which is the hypotenuse. Okay, it's the side opposite the right angle. All right, so you got A, B, and C when we're dealing with Pythagorean theorem. All right, but it's always with right triangles. Okay, so you got your leg here A, leg here B, hypotenuse C. All right, so let's talk about example 1. Here in example 1, if we take a triangle, oops, helps if I have the pen working. There we go. So there's a triangle, and of course he is a right triangle, all right? And this leg is 5, this leg is 12. We don't know this leg, this is C. We want to figure out the hypotenuse. So you could call 5A and 12B, all right? And your formula for Pythagorean theorem is A squared plus B squared equals C squared. And now what we're going to do, guys, is just plug in values and solve for C to figure this out. So here's how we go. We're going to go 5A squared, which is 5 squared, or to the second power, plus 12 squared equals C squared, okay? Now, might need your calculator out. In fact, I'll even get mine out here on my phone. Not that you can see that at the moment. So you think, okay, well, 5 squared is a pretty easy one. That's 25, right? So we're going to have 25 plus 12 squared is 144 equals C squared. Now we're going to add these two together. So 25 plus 144 is going to equal 169 equals C squared. Now some of you are thinking, okay, so the length's 169, right? Okay, here's the problem. C squared really means C times C, right? C to the second power means you have 2 of them. We need to get rid of one of them. So to do that, the opposite of squaring a number, or the opposite of taking something to the second power, would be to do its square root. So we're going to take the square root to both sides, because what you do to one side, you have to do to the other. And that's going to cancel those 2 out, which leaves me with just C. Then you take the square root of 169, which is 13. So the length of side C up here is 13 units. Okay? That's how we find the hypotenuse. Again, we just plug in values, we squared them, added them together, and then took the square root of them, so that you got rid of that second power right there. Okay, your next example, we want to figure out a leg. So in our triangle, whoops, again, it helps if I select the pen here. Right triangle, we have this leg is 7, this leg is B, we don't know him, and the hypotenuse is 14. So again, this would be A, we already told you there's B, this would be C. So we go back to your formula, A squared plus B squared equals C squared. I would keep writing this every single problem until you've got it etched into your brain and you'll never forget it. So A squared, we're going to say is 7 squared plus B squared equals C, whoops, not C squared, whoops. Sorry about that. C is 14, so it'd be 14 squared. Okay? So 7 squared is 49 plus b squared. 14 to the second power is 196. All right. Now, here's the difference. We need to get b by itself, so that means this cat right here has got to go. So we're going to subtract 49 from both sides. Those zero out. So now we have b squared equals 196 minus 49 is 147. Now again, that's b to the second power, so we got to do the square root to both sides. That's the opposite operation. Just like we subtracted 49 because he was a positive, or just like you divide by 2 if it's 2 times x, you take the square root because it's opposite of squaring a number. So we're going to have b equals, and you take the square root of 147. As soon as I find the square root button on my calculator. There it is. And we get 12.1. It's all right if you got a decimal. So length of that leg is 12.1. Now you figured out what the other leg of that triangle is. Okay? Simple algebra. The only thing really new that I'm throwing at you might be taking the square root. Okay? But just pay attention to what you're doing, squaring numbers and getting things together. Okay, now on example 3, this is slightly different. If we have a triangle and we're given coordinates, okay, like here's point A, point B, and point C. And point A, his coordinates are 1, 2 on the coordinate plane. B's are 4 and 6. C is 4 and 2. And they're asking us to figure out the lengths of these segments. So first off, we're not able to figure out the length of the hypotenuse just yet. We'll actually do that here coming up in the next example. But what we can do is we can figure out the length of B to C. And to do that, we're going to take the y values of these 2 points and subtract them. So this is really going to be 6 minus 2, which equals 4. So the length of this leg is 4. Maybe we'll call him the A leg. And the B leg over here is going to come from subtracting the x values. Since we're going across, that's why we use the x's. We use the y's here because we're going up and down. So my x values are simply going to be 4 minus 1. So 4 minus 1 is going to equal 3. So B, the length of B is 3. Now, once we have the lengths of our 2 legs, now we just plug it into the Pythagorean theorem like we did in example 1. Okay, so I'm going to scooch over here a little bit. Again, a squared plus b squared equals c squared. Now we plug in values, so it's going to be 4 squared plus 3 squared equals c squared. 4 squared is 16 plus 3 squared, which is 9, equals c squared. Add those two. We get 25 equals c squared. Now we take the square root to both sides to get rid of that little power of 2. And the square root of 25 is 5. And now we found the length of this other side, the hypotenuse, is 5. Okay? So the only thing different here we threw at you is that if you need to figure out, if you're given coordinate points like this, if you're going up and down, subtract the y values. If you're going across, subtract the x values of those coordinates. And then just plug it in like we did before. Let's talk about example 4, which is basically, what if I want to figure out the hypotenuse of the triangle? Okay? But maybe we're just given some points. Or maybe we just want to find the length of a segment. Okay? So for example, if I have a point here going down to a point there, just on the coordinate plane. You pretend it's on a grid. And this is point D, and his coordinates are 1 and 2. It's a 1. And this is point E, and his coordinates are 3, -2. We want to figure out how long it is from here to here. So here is the formula you're going to use. This is called the distance formula, which means I'm going to use a small d for distance, equals, take a big long radical, and you take your x2 minus your x1, and that's going to be squared, plus the y2 minus y1, and that's going to be squared, all underneath the radical. So here's how it goes. My distance is going to equal, big long radical, x2 is going to be 3. If you want, it would be helpful, I'd say this is x1, y1, this is x2, y2. Why would I label this one the first one and this one the second? Because as I work from left to right, I come to this point first. That's why I call it that one. If you did them backwards, you should be fine, so long as you made sure you used both. You went x1 here and y1 there. But just follow what I'm doing here. So x2 is going to be 3 minus x1, which is 1, and that's going to be squared, plus y2 is -2 minus y1, which is 2, squared. So d is now going to equal radical. 3 minus 1 is 2, and that's going to be squared. -2 minus 2 is going to be a -4 squared. So now we're still in the radical. 2 squared is 4, plus -4 squared is 16, which then gives us the distance will equal radical. 4 plus 16 is 20. Now you need to take the square root of 20, and your distance is going to be 4.5. That is how long it is from D to E, 4.5 units. Okay? And that's how you use the distance formula. All we're doing is plugging in some values and doing a little bit of math. Pay very close attention to what I did in these sections here, okay? Worked inside the parentheses first, PEMDAS, right? Got my answers, then I squared them. Okay, parentheses, then exponents. And then we just added, and then we took the square root in the end. Okay, that is about everything here. A lot going on in this lesson, but watch it again if you need to. All right, hopefully you took good notes. I do hope you have a great rest of the day. Bye-bye now.